student, Kiko, and then we also have Justin Elliker over here, and we also have Danielle Fletcher? Yeah, Danielle Fletcher over here. How's it going with you? Today we're going to basically be doing a lab. Now, Kiko, um, do you think that you can get a second to sort of try to gather some materials and go maybe ask your mom or is there anyone else at the house right now? Is there anyone else in your home? Your dad's here. Okay, maybe you might want to ask if your dad can help you out with this lab while we're doing it because this requires two people, and I've got two people over here. And let me just kind of give you the basic heads up. Do you want me to give you a second? You can ask your dad if he can help you out with class. Maybe you can spend a half hour with us and talk with us. By the way, Kiko never answered whether or not she's a boy or a girl. Oh, okay. I thought, right, I asked, right? Remember? Yeah, I thought that was okay.
This thing records.
Oh, okay. We're going to. I need him to help you with the lab because it requires two people. If not, you can just watch what we're doing, and then get someone else to help you with it. Um, and I'll tell you what. Don't have him help you right now if he's really pressed for time. Um, I'm just later on. Maybe I might ask, and it will take him like 10 minutes, I think, to do. Is that cool? Or if he wants, he can sit in and watch the whole lesson with us. It's up to you, but I need to go over a bunch of equations with you before then. Is that cool? Ah, all right. Kiko, you ready? We ready? We ready to go? I want to start. I'm excited. All right. I'll watch since I can't hear well anyway.
Alright.
Darn.
Really wish you could get like a better microphone or something.
I have a USB thing, but when I plugged it in last time, it didn't work. All
What
right.
about this
I'll
thing
tell you
right
what,
here?
Kiko. Maybe it might work better.
It
Let's try
has
it.
two ins. It has two ins, one for sound and one
Well,
for.
no, it's got an in and an out, so let's just use the in.
Alright.
Kind of broken the sound, but Kiko, can you hear me better?
There you go.
Kiko, can you hear me better? I got this weird thing in front of my face now, and I keep on wanting to go like this. Is that any better? I should type it. Huh?
If that's what.
Can you hear me at all? I guess
I
so.
need that
All right.
tracker program.
Awesome.
I
Good.
should do
Okay.
the web interface.
Here's what we're going to be doing. All right. Today, what we're going to do is we're going to be doing something similar to this. Now, I'll show you what I want you to do. Justin, I want you to hold the dollar at the top like
Is
this.
this the dollar trick?
It's not a trick. All right. All you got to do is drop the dollar. Go for it. All right. Now I got to try to catch the dollar.
Yep,
Okay.
it's the dollar trick. It's the
All right.
dollar trick.
So
The
wait,
trick being.
James. All right. So all you got to do is I'm going to put my fingers down here at the bottom, and then you drop the dollar, and I've got to catch it. So you can drop it anytime you want. You don't tell me, and I'll catch it. Dude, you just drop it. Don't
I,
like.
ca- I fail at dropping the dollar
You just got to let go of the dollar. Okay, go. Oh, I caught it. That was easy. Come on. Oh, wait, no, no. You don't go
It's
higher. You go right at the thing. It's harder when it's down here. There we go.
the
You
further
got
your
it?
distance is,
All
the
right.
harder it is for you to
Your turn. Your turn. This is Danielle. This is Danielle. You ready? Let's put the camera on Danielle. There we go. Danielle, you ready?
Okay.
You ready? I'm gonna drop the dollar. You gotta catch it. You ready?
Danny, please.
Let's do it again. You ready? Oh! No, I'm kidding. Okay. You want to go about an
Stop
inch
trying to
apart.
psych her out.
I'm not trying to psych her out. I'm just gonna drop the dollar.
Okay, I wasn't ready.
Okay. All right.
Keep
Fine. Fine.
thinking
Tell
like
me
you're
when
trying
you
to
are
do
ready.
that.
Okay, go.
All right. Justin, you said you know the trick.
Yeah,
Don't tell me the other trick. Just do it.
I know about it.
Okay. Ready?
Yeah. I know that it is physically impossible for you to do that because it falls faster than your brain's
How
nervous
is it
system.
physically impossible? I did it twice.
It gets harder and harder. The
Fine,
more, it
fine.
gets harder and harder.
Danielle,
the more
you can hold the dollar. I will do it again.
It's a physics trick. They use it to cheat people out of money.
Ready?
And do it all the time.
Dude, I'm catching it every time.
It's because it's a still air. It's still air. There's barely any air movement in this area, so it's very easy to catch it.
So wait, you're saying that if you sit in my seat, you can catch it, and instead of sitting where you're sitting?
No, I said exactly what I meant. It only works in areas where the airflow is turbulent or unknown. Because it's very hard for your eye to track the position of the dollar, and your nervous system message will travel slower than the dollar does.
You just gotta admit that this old man is faster than you guys.
Okay, I will admit that.
Okay, I'm just saying. All right, that's what we're gonna be doing.
The vast
today.
majority of people will.
We're gonna catch your reaction time.
Alright.
Now, I guess my reaction time is a little bit faster than yours.
Yeah.
That's sad. I mean, really? Okay, fine.
How
I
old
guess-
are you anyway? You look 30.
I'm like 30 something.
Oh, okay. And you're actually like 42.
I'm like older than 30. All right. Anyway,
I can
you,
be as
you
old
guys,
as I need to
you want to
be.
try it again? Oh, challenge now, huh? Okay. Ready? Close. It was close. and Mr. Dalde can. All right. All right. Anyway, that's what we're going to be doing today. And what we're going to do is we're going to figure out how long it takes for your brain, like you're saying, Justin's going all over this. You have to, when you drop this thing, Justin, tell me about it. When you drop this thing,
Your eyes are trying to track the
all right,
position of
so
the
your
dollar.
eyes track the position of dollars. Your eyes tell you, hey, dollar's moving. Then your brain tells your eyes what?
Your brain tells the muscles in your eyes to follow the dollar, and then it tells your arm to move
To
down
squeeze,
and
and then you squeeze your and by that time the dollars fall.
yes, gravity acts faster up the gravity, and everything's.
And for some reason, Mr. Dalde can catch it, and he's twice the age of these youngins over here.
I'm 17.
Right?
Oh, you're like maybe 34 if you're plus.
About twice his age, actually. Yeah. Okay. So, for some reason, Mr. Dalde is twice as fast and also twice as old. All right. Anyway, I'm going to introduce to you guys 4 equations. Those 4 equations are this, and I want you to write them down. And if you don't want to write them down, actually don't write them down because I'm recording this session anyway, so you guys can just watch the archives as you like doing it and do that. Which archives do you watch? Do you watch the videos, the YouTube videos that I put up? You watch the conferences?
Yeah, I go to the conferences.
All right. Anyway, I'm going to introduce you 4 equations, and I want you to look at them. Okay, ready? It's I'm going to do this from my head, and it goes V equals V naught plus AT. I'm going to show you another one. It's delta X equals V final plus V initial all over 2 times T. Another one is delta X equals V naught T plus 1/2 AT squared. And the last one is V final squared equals V initial squared plus 2A delta X. I told you yesterday, actually, or I told you yesterday, you weren't there yesterday, were you?
There were only 2 other people in there besides me and you.
All right, well, you might want to show up for class because we cover some pretty crazy stuff. But anyway, I told you yesterday that I would be introducing you to the 4 kinematic equations. These are the 4 kinematic equations right there. Got it? In fact, I'm going to write them at the top of the board because I'm going to erase this because I want some space to write. So I have V equals V naught plus AT. I have delta X equals V final plus V initial all over 2 times T. I have delta X equals V naught T plus 1/2 AT squared. And I have V final squared equals V initial squared plus 2A delta X. Now, I have a question for you. Are you scared of these equations?
Unless they were covered in sort of marking down the dark I would not be afraid of it.
Okay. Whoa. Whoa. I've never heard that response. Are you scared? I'm kind of scared of you. I'm
I'm not
scared.
scared of
But
physics.
are you
I'm
scared?
not scared of physics.
Well, no. I'll be honest with you. These equations look very intimidating to me.
They're daunting.
If I looked at it for the first time, I'd be like, dude, I don't know what you're talking about. Like, that's crazy stuff. I mean, imagine if you're sitting in Starbucks and you're writing these equations down. Your board looks like, your paper looks like this. Would people be like, oh, yeah, we got that. We learned that in kindergarten. You didn't learn this by now?
No.
You learned this in kindergarten if you lived in China.
Well, that's true, actually. That is true. But what I'm saying is, like, are you intimidated by these?
I'm intimidated by the standard measure. You know the standard measure equation?
No. We're not talking about standard measure equation. By the way, Justin, we got to bring it back. I'm asking you to focus. It's not too advanced. And actually, to be honest with you, sometimes you talk about things that you think are too advanced and you don't really know what you're talking about. So, this is what physics is. Let's talk about these four equations. We have, all right, here. If you're intimidated by them, let's talk about how to use them. And then let me show you where they come from. Because my biggest pet peeve is people pulling equations out of their butt and throwing it up on the board and saying memorize this. And I'm showing you these four equations, I'm saying memorize this. So literally right now what I'm doing is pulling this out of my head, out of thin air, throwing it up on the board and saying memorize this. Right? Because this is actually going to be useful. And I'm telling you, memorize this.
It's stuff that he.
It's not even that hard to memorize. But anyway, because you know why it's not going to be that hard to memorize? Because I'm going to show it to you so many times that you guys are going to be like, oh my gosh, I'm going to use this. I got it memorized now. Okay? It's almost like after we made you do like 20 quadratic equations,
Oh, yeah.
you guys were like, oh, that's negative b plus minus b squared minus, or square root of b squared minus 4ac all over 2a. Right? You had it memorized, not because it was fun,
Repetition.
just because you've used it so many dang times that, like, you had to memorize it. Or you didn't have to memorize it, but it just kind of got stuck in your head. Same idea, all right? Anyway, let's talk about how to use these equations. What do you think v represents? The v.
Velocity.
Velocity, there we go. What is v in v0?
Starting velocity.
The starting velocity. So there's two different velocities, and we don't want to call one v and the other one v and not be able to distinguish the two, so we put a little zero by it. And what that kind of tells us that means the initial velocity. Kiko, can you hear me? Kiko? So, all right. I'm sorry that if it's not good. This is the best I got for now until I can get my Mac up and running again. All right. So we're good with V and we're good with the V naught. Okay. What about the A?
Acceleration.
Acceleration, right? What is acceleration? We're introducing that concept to you. You've learned it before. What is acceleration?
Velocity over time.
No, it's.
No, here. On the board.
Go for it.
Acceleration equals change in velocity over time.
There we go. It's how velocity changes over time. It's kind of analogous to how velocity is equal to delta x over t. Does that make sense?
It would make sense to me if you told me what x is.
Well, x is your position. So velocity is the change in position over time, just like acceleration is the change in velocity over time. Or you can kind of think of acceleration as the change in the change of position over time, right? It's like a delta x, I guess. You want to think of it like that.
Delta of x.
Yeah, something like that.
To relate it to something
All right.
different.
And then the t stands for time. Good. And the delta x, you know what that stands for?
Change in position.
It's the position, the x, right? But we talked about displacement, so it's the change in it. So you're talking about the delta means final minus the initial. Anytime you see a delta anywhere, it means the final minus the initial. Does that make sense to you?
Yeah.
Cool.
The range.
Yeah. I don't want to say the word range because I'm going to reserve that for something else. But It's the change of.
Change of.
The change of. Like, delta means change of. So if I have a delta x, that means the change of position. If I have a delta v, that means change of velocity. We cool? So, can you use these equations? This just tells you that the velocity is equal to the initial velocity plus at. This just tells you that the change of position is equal to the two velocities added together divided by 2 times t.
Pardon me. We'll know what to use this for.
I will show you the situations in which you will use them. I will show you where they come from, and I'm going to show you. Well, right now, all I'm doing is, can you read them?
Yeah.
Kiko, can you at least read them?
Can you even?
Yeah, I apologize if you can't hear me. I'm doing the best I can with this one, but.
But if you're gonna put it against, you put the microphone against your. No, against your cheekbone. Against your cheekbone.
All right, there we go.
It should be slightly muffled, but that's you hear you how you hear yourself.
She. I think it's a she.
I don't know. It's hard to tell. I can't see your face.
Kiko, can you hear me better? I'm literally like eating the microphone. It's touching
She
my
says
face. Yes, she says she. All right. Apparently, she can hear us better.
All right.
All right. Anyway. All right. So let me show you where they come from, because actually, you guys are like. All right. Well, I'm gonna do my best, Kiko, and for now, let's just do that, and then I'll send you the video of this archive, which will be better. That is a big old fly.
That is.
It's going outside. All right. I'm gonna erase this, but don't worry, I still got the equations up top. Cool. All right. Now, I was just teaching an Algebra 1 class. Those kids out there, they're Algebra 1 students. Got it? You guys took Algebra 1, right?
Yeah.
What are you? Calc? AP Stats.
Pre-calc.
Pre-calc.
The only AP classes.
Kiko, you're calculus, right?
The only AP classes I'm taking are chemistry and English.
Okay.
I can't take AP everything.
So you've got this Algebra 1 stuff, right? All right, so check this out.
All right.
I just taught my students this equation about a line. It starts with a y. You guys know the equation of a
Y
line?
equals MX plus B.
Y equals mx plus b, right? Right? But this time what I'm going to do is I'm going to do a different graph. I'm going to have the velocity graph
Over the time.
as a function of time.
It's the same thing. No matter what the graphs are labeled, you should be able to recognize.
Okay, so then let's write down y equals mx plus b.
That's
But
easy.
this time what we'll do is we'll change it using our variables here. So, all right, go for it. Justin, you can go do
We'd
it.
replace this with V.
Okay, replace that with b. Then what?
You replace the X with. You replace the M of X with.
We'll just do the x.
Well, because if I do it, I would do like F of T or something.
No, you just stupid. T. Okay, we good?
Sorry, I have terrible handwriting.
No, that's good. That's fine. All right. What do you think that? What is the b? Let's work on the b part.
B is the y-intercept.
Yeah. So it would be.
Hold on. So it would be. That's the closest thing. That's the closest I can get to it. I know it's not right, but it's the closest I can get.
Yeah. Okay. Here's what I'm gonna put. I'm gonna write something down. I want you to tell me. Oh yeah, that makes sense. Or oh, that doesn't make sense. I'm gonna label that as this.
That actually does make sense, given what we already know.
Well, what does v naught mean?
The
So starting.
The velocity at time equals 0, right? Which we know as the y-intercept, or the b-intercept in this particular case. We cool? All right, what about the m? What is the m?
The slope.
The slope. So that's the slope of your velocity time graph is what? No, but you were half right. No? What is the slope? If I measure the slope, that would be the rise of the run. That would be the change in velocity
Over change.
divided by the change in time. That is known as acceleration. So this m is really just a secret code for a. Does that make sense to you?
So can you erase the T?
I can raise some parentheses. I can just put a T. Let me write it a little bit nicer. V equals AT plus V naught. Right? Now, where did I get that from? Where did that equation come from? Y equals mx plus b. It wasn't that bad, right? It's what I taught the Algebra 1 students. Do you see, does this look familiar to you? It's the first equation. So there's 4 equations of motion, the super complicated one that I'm talking about. That's it right there. It's just y equals mx plus b. That's it. So now are you afraid of it? I mean, you're in AP Stats. You took calculus last year. I mean, this should be like, I got this for you. All right. So I'm not afraid of that one. Why would I be? It's just y equals mx plus b. Let's look at the second one.
I can recognize that one.
What is that? It's a different concept.
Isn't this the ax squared plus bx plus c? Isn't that what that is?
No, we're talking about this type of velocity.
Okay, because it looked similar.
Okay.
My brain kept
Telling us what it was.
No. This one right here.
this one. It doesn't look similar to anything
Delta x equals v final plus v naught all over 2 times t. I'll show you where that comes from. Would you like to know? Okay. If you are traveling at a velocity of 50 miles per hour and you drive for 2 hours,
And you keep
how
that.
far did you go? I'm not trying to trick you.
Is the velocity
If you
continuous?
drive at a constant velocity at 50 miles per hour and you drive for 100 miles, no duh.
Because you're just cutting the
Right?
cutting the
Seriously?
time travel.
Yes, okay. If I were to graph that
It would be a straight line.
it would be a straight line at the value of 50.
A straight line.
And if I told you I was going for 2 hours, how did you get 100?
That's 200 cut in half.
50 times 2. Right. So you multiply those two. Right? If I
That's
multiplied those two and I showed you on the graph, what would that actually give you?
The equation is true for all.
No. What is this called? Right here, this shaded part there. Oh, come on.
Function
It's
area.
the height times the width.
Function area.
Oh,
Function area.
It's the area.
Function area. Yeah, I remember learning that.
It's just the area.
yeah.
Right?
I remember this
It's
when we
not
were learning about
easy.
this is
Because
inequalities.
if it's 50 high and it's 2, the base is 2 and the height is 50, then your area is 100. Right?
It is to apply.
Which is the same as the distance you travel. So now I'm going to make an argument, and I want you guys to tell me whether or not you think it's correct. I'm suggesting from this idea to you that if I have a velocity time graph, and I figure out what the area underneath that curve is, now you're thinking, oh man, that's integration, isn't it? Yes, it is. That's where we get integration. That's why we do integration. But if I have a velocity time graph and I figure out the area underneath that curve, that would give me the distance I traveled. Do you agree?
Yes.
Yes.
Yes, awesome, good. Now, I don't have that. I don't want to talk about moving at a constant velocity of 50. I want to talk about accelerating, moving.
That is not one that is B and it is L for blood.
Okay, all right. I'm going to talk about a accelerating velocity. I'm talking about something that is getting faster and faster and faster. So, let me ask you this. If this goes, let's say it's 50, this goes up to 75. How would you figure out this area? Now, what area am I talking about? I'm talking about this area.
Oh, that's Pythagorean
Theorem.
Would it be Pythagorean theorem? It's a lot easier than that. 1/2 base times height. So you would take half of,
Yeah, that's what it is.
what is your base is 2, right?
Why is my brain doing?
2 times the height. What's the height? No?
Wait, just the
1/2, 2 times, what's the height?
25?
25. How'd you get 25?
75 minus.
So you subtracted that from that. All right? What's the area of this? I would close that, but the problem is it gets super hot in here.
I'm opening.
That would be fine. That would be fine. If you guys just get hot and I start getting stinky, don't blame me.
I'll wedge it open using this box over here.
No, I'm fine with that. I'm loud. She's loud. But I'm just letting you know if it starts getting hot and I get stinky, it's not my fault. You got that. You got the area of this. It's easy. 1/2 base times height. I'm not introducing you tough concepts here. I think the hardest part that you guys are having trouble with is like this is so easy that you're like he's trying to trick us.
Yeah.
All right. What's the area of this? That would just be base times height, which is 50 times 2.
Something you
Cool.
already learned.
Cool. Awesome. And so if we want the area of this, we just add these two together, right? So now I'm going to take away the numbers. I'm going to switch them with variables. This is V final. This will be V initial. What is the area in here? Oh, this is T. What's this area? Is that your phone?
No.
Is that my mouse? Okay. It's all right. Don't worry about it. What is that area right here? Come on. We're running out of time.
The initial velocity.
There we go. V naught times T. Are we cool with that? All right. What's this area in this triangular part?
Sure.
1/2 T times what?
The
Vf minus V0. Good. Awesome. Now I'm going to add those two together. What did I do?
Can I get your measure?
It's got some stuff on it.
It was part of a physics experiment.
All right, so check out. What I'm going to do is I'm going to add these two together. So I've got 1/2 V final minus V naught all times T plus V naught T. Did I confuse you? Did I lose you?
No.
No, we're good? And I told you that I made an argument with that that's equal to delta x. That's the distance that you travel. All right, fine. Distribute this 1/2. Distribute this T. I get, all right, 1/2 V final times T minus 1/2 V naught times T plus V naught times T. Can you guys do this in your head? Justin?
All right.
Can you just do 1/2 times the V final and then 1/2 times the V0 and the answer minus the other answer?
Yeah, all right, fine.
And then times the V2.
You're going in the right
Yeah,
direction.
sure. Let's just pull out T all the way. Is that what you're saying to do?
Yeah.
Evaluate T.
Yeah, you can totally do that. That's fine. Let's just do that. Let's pull out T all the way until we have 1/2 V final minus 1/2 V naught plus V naught.
Wait, but there's two T's, so when you have to split.
No, because I pulled out a T out of here and pulled out a T out of there.
And you just add them together, and since we don't know what T is, we can't say it for sure whether it's T
Yeah,
or
but for now, this negative 1/2 V naught, that positive 1 V naught gives me what?
Positive. We give you positive.
positive 1 would be positive V naught.
Nope.
Positive half of V naught.
Yep.
And then you would multiply that by T, but until you know what T, but until you know what Vn
Well, let's do this. Why don't we pull out this half? Sound good to you? It's in both terms.
So now
we
we
got half T.
I'm just going to do this. Sound good?
That looks a little less. That looks a little less.
This is equal to delta x.
okay. So you're doing.
Deriving. That's the last equation.
Dude, seriously, this was y equals mx plus b. This is the area of a triangle and a rectangle. You guys are telling me, you guys are afraid of these equations. Y equals mx plus b. Area of a triangle and a rectangle. I think that I really could teach this lesson to like 5-year-olds.
I taught a 5-year-old quantum physics.
Maybe not 5-year-olds, alright, I admit to you. Maybe I can teach this lesson to 5th graders.
Easily, and they would get it if you explained it enough.
Well, no, I don't think I could use the variables. I think the variables freak people out, but I'm just saying.
Even at that age, they
All
might-
this is y equals mx plus b. All this is areas. Does that make sense? Are we cool with that? You afraid of these equations? Not yet? Well, I don't know. The last two look kind of funky.
We're trying to make you not afraid of
All right,
not
fine.
afraid of your
If the last two are kind of funky, where's my?
Fear
Thing.
stuff, it locks
It's
up.
not how your brain functions.
Yeah, well, that's what I was trying to teach you guys to do with Fermi problems. I'm trying to teach you guys to think.
Fermi equations?
The problems. You remember like how many hairs are
Oh,
in your
yes.
head or that kind of stuff?
Yeah.
Did you like those kinds of things?
Yeah, but how does there's an human has similar close to similar between the population of the US and the population of China?
Okay. All right. Anyway, where did I get this third equation? I'm going to give you a hint. In today's lab, all we're going to be focusing on is this third equation. All right. Now, I know that it feels like, wait a second, I thought today was lab, and all you're doing is lecturing us, right? And I hope that you guys don't feel like I'm doing like this boring lecture.
This is not a lecture. You're trying to make it as fun as you can. Like, you're genuinely
Well, no, but what I'm trying to do is I'm trying to like give you the background because I swear to you, I cannot stand how much when teachers introduce these equations, they don't explain where they come from.
Yeah.
Let me show you where this third one comes from. It's not that bad at all. I'll show you what it is. All I'm going to do is I'm going to say, all right, I know this equation, number 1. I'll call this a 1. Got it? I'm going to call this equation 2. I'm going to take equation 1, and I'm going to plug it into equation 2.
And then we simplify it.
And simplify it. That literally is all I'm going to do. In fact, how good are you at algebra?
Let me guess,
Pretty
that is
good.
the is
I
that
guess.
equation right
You're pretty good. Then why don't you and
Is
Justin do
this
it?
equation that what comes out of it?
Here,
Wait.
Justin, I want you to take equation 1, or Justin, I want you to take equation 1. I want you to actually take equation 2, but instead of writing a v final, I want you to replace it with v naught plus at, because equation 1.
It's gonna get pretty hairy.
Here.
Position the camera up a little more.
I'm turning the class over to them for now, and I'll help you. Now, this both of you guys can work on this. And just keep in mind that there's a camera right behind you, so always have to back. Please. It's not that easy.
So you're basically saying that the final velocity is this equation?
This first equation, right? The final. I'm going to take the second equation and instead of writing, yeah, exactly what Justin said. All I want you to do is simplify.
And then you would just combine like terms. Distribute v of 0 over everything. And you would get v of 0.
Oh, and then I want you to, just solve for, just solve for delta x. So we'll keep delta x on
Squared plus v of 0 v of 0 at.
Wait, but you don't need over v of 0, right? Which is v of 0 squared plus like v2.
Right. This is Danielle. This is Justin.
Okay. You want to take
guys
over?
are disagreeing.
You want to take over for me? We're not gonna fight. This is math.
Round 1. What do you say? Danielle?
What do you choose?
Because you already have v of 0 squared, which is v2 v0, so why do you need the third one?
Why do you have v0 squared in the first place?
Because
I'm distributing it over both terms in the
I'm telling you now that v0 is wrong. Why are you
Wait,
distributing?
yeah, you can't distribute because it's addition. I thought it was distributing too.
Okay,
Wait,
guys.
let's start over.
We both had an
We're
immense
sitting
brain
across
fire.
your ears. Okay. Okay, all right, no, that's fine. That's fine. That's what you have.
Let's just erase the
No,
entire.
no, just erase that part of this part.
No, just erase that second line. The second line's wrong. The first line's good.
Now,
Well, do you need those parentheses? That's my second question.
Probably not.
No.
Because it's added.
If you're adding, then
you just combine these two, so you just get
2v naught.
plus at divided by t times t, which means
No, not divided by t.
Sorry, okay, because that was like it would just simplify to v over.
Now, don't erase what I have up on the board. So hold on. Use a different color.
want to continue.
And Daniel, if you want.
If I start to get confused or speak gibberish,
Justin dropped it underneath the table. want, yeah, you can use a different color. It's fine.
Okay, then multiply the entire equation by t. So that would simplify to 2v of 0
What's not working?
plus
Establishing the center of
t plus
Create.
plus
Like that.
a t squared. Identify the and still that all over
I
2.
can hold on shift, right?
We're establishing the fact that it's only the t we're multiplying by itself.
These twos cancel each other
Oh, would they? Okay. And these t's then that does not exist. This t does exist. Oh wait, hello. Why did I do that? It's not even divided by anything in the final equation. Alright. There you go.
Wait.
I put the parentheses to signify it's only the
T that you're multiplying by itself, not the entire expression.
and that A is the coefficient of T, even though
It's a
I've
variable.
done that. I pulled up auto
See anything wrong with that? I think that
Let's
right.
shift with that using the individual control as well. You guys, what are you guys fighting about?
Okay, well, first of all, this 2 cancels out that 2, so then just cancel that out, and that's just that's how it's
Wait, just move from the side. I don't want to see your butt. I really do think it's really good. It's not as great as you think. Well, I'm sure the eco doesn't necessarily. I don't know. But
No one should be staring at my butt.
well,
Maybe
you're the one
not,
standing right
maybe
in front of
not.
the camera. All right.
It's very hard for me to
That
do
two on
things
top
like
cancels
that.
out with that two on bottom. You guys are making me call into question your algebra skills. Yeah, almost. Halfway there. That is actually wrong in the algebra world. This is algebra 1 stuff. Okay, fine. I'll give you a break, but then you had to reinforce your algebra with your calculus skills.
I'm just starting pre-cal, so
Please be gentle.
All of you guys have had algebra 1 at least. You have had, all of you had algebra 2 for that matter. You should know how to do this.
I only did half a year of algebra.
Alright, fine. I'll tell you what to do. You put another. The 2 cancels. This 2 is on this first term and that second term. Right?
So
So
any
it does
two-
cancel out the first one, but it doesn't cancel out the second one.
Oh, yeah.
Okay.
We're missing something.
No, that's it. You're done.
Is this the entire equation?
You're done.
Okay, so mind telling me what this equation even means?
It's right there. Delta x equals v naught t plus 1/2 at t squared.
Oh.
Okay, and then we went.
It's the third equation.
Then what about then where do we get the
Okay, I'll get to that, but I mean, I'm waiting for you guys to at least say, oh, that's kind of cool.
If I understand it, I'm not going to say I
understand it. I'm just gonna know how to do it.
It's a sad word to exist.
The teacher should be able to tell if I understand it or not by how much faster get right in my homework.
I can tell that you understand. I just want you to be excited about it. This is y equals mx plus b, right?
I'd be excited if I solved the millennium
This is
problems.
straight up just area.
So then what?
This is just the combination of these two easy equations. So this third equation isn't even really that hard.
Then what about
Wait,
the
but
fourth?
what?
Then what about the
Oh,
fourth
it's the.
I'll get to the fourth one here. Oh, you want to see me
one? How
do
do
the
we
fourth one?
combine the
Alright,
first
fine.
two equations?
Fine. You want me?
Wait.
Justin, calm down.
It's just rewriting the.
You just asked me to find the fourth one out. If you want, I'll do it for you. Or I'll tell you what. I will tell you what. Because I'm so tired of doing this lecture. Not tired of doing this lecture. This is actually one of my favorite lectures to do.
I'm more engaged than I've been in anything.
Well, good. I'm
all
glad.
month and a half.
But what I'm saying is, I'll tell you what. I'll challenge you then, and I'll say, I've proven to you how to get the first equation, the second equation, the third equation. They're all not that hard. I'm gonna make you go home and prove that the fourth equation is correct, and I'll tell you even how to do it. You use the first equation and the second equation, and do something very similar to what I did to get the third equation. All you do, you only need to use the first and second equation, and you, instead of substituting in for v, you'll substitute in for something else.
T.
Why t? How do you know that I should have substituted for t? He's right, by the way, but I'm just saying. Why t?
I don't even know. I have data names in my pockets right now.
I don't even know what that means.
I'm flying by the seat of my pants.
I like that. That's fine. Well, no, if you look at this equation over here, is there a t in there? If you look at this equation over here, is there a v final in here?
There it is not. As you can
What
see.
did we substitute when
We
we
eliminated it
From the original
when we
equation.
substituted? We eliminated v final from that equation. So the hint that Justin gave you, and that's pretty much now the problem is pretty much done for you. Now it's just an algebra exercise, which I still encourage you guys to do because it seems to be you guys got to work on your algebra skills. But all you got to do is take this, eliminate time from these two equations, and you get this fourth equation. That's it. Okay. So
Wow, that was way easier than I thought it would be.
I had no idea why my brain said T.
I'm glad it was way easier than I thought it was. Can I erase
Why
this?
did my brain
Yeah.
say that?
So now here's
It's
what
all
we're
that
gonna do.
hilarious secret thing is.
Well, maybe it's just because you're secretly understanding what I'm talking about. All right. We're going to focus in on this equation right here. Delta x equals v naught t plus 1/2 at squared. In fact, for the next couple of days, you guys are probably going to be using this equation so much. In fact, not even the next couple of days. Next, like 5-6 weeks, you're going to be using this
Rest of
equation
the
so
semester.
much
Rest
that
of
you guys
the-
are going to be like, oh, this equation, you know,
Almost rest of the
you'll have it memorized in a couple of weeks, I guarantee you. Okay? And now you're no longer afraid of it because you know that it's not necessarily like super complicated. All right. Now, how would I figure out what my reaction time is if I told you this equation? Now what we did was we dropped the dollar, okay, and Mr. Dalday caught it every time, right? Dude, the camera's right here.
Okay.
Your
if I
butt
were to-
is over here, so I'm just letting you know.
Mr.
If you don't
Dalday,
want
if I
anyone
were
to
to
look at your
Create the
butt-
equation to derive reaction time. I would put in a lot, it would look a hell of a lot more complicated than that part of my first.
But it's not that complicated. It's this complicated. That's it. That's not even that complicated. This is what physics is. I'm telling you that this is what physics is. We're not trying to make things more complicated. Yes, this does look intimidating. I agree with you. Is physics hard? It actually is hard. But this part isn't hard.
I would have actually factored in
Okay?
like.
And I think that it's hard, and I feel like it's hard because everyone is afraid of it. Not because it's actually hard, because they psych themselves out. So what I'm trying to, my goal is to show you the equations, say, look how crazy it looks, but it's not that bad.
Please make your free textbook more popular.
I'm trying. All right, so delta x equals v naught t plus 1/2 at squared. Now what we're going to do is we're going to calculate my reaction time. I'm going to give you an example problem. We have $1. Can I borrow that pen instead?
This one's starting, that one's starting to run out of ink. I can tell by how it smells.
I have $1. $1 is 6 inches.
And it weighs about a gram.
Here, I'll tell you what. Why don't we just do this?
It weighs about a gram.
$1, you don't need mass.
Oh, okay, you just need the area.
$1 is 16 centimeters.
And how much? And it's about 2 inches wide.
You got it?
So
Right.
about 2 inches wide. And it's
I don't
taking
even
a
need that. I
millimeter.
just need 16 centimeters. 0.16 meters. Got it? Agreed? Sit down in that chair. That way you're not in the way. Alright. 0.16 meters. Mr. Dalday grabs the dollar. Let's say his hand is right here. And okay. The dollar falls. And Mr. Dalday grabs it. I grab it about halfway. Why don't we try it again? You wanna try it again? Do you wanna try?
I can't
You
tell
kind of
the
do
air.
that.
I can't get the
You're kind of like, I'm gonna get
I'm
this.
just hidden in the air somewhere.
Really in here. I'll
It's
tell
like
you what.
hidden airflow somewhere.
I'll tell you what, Justin. Do you want to try?
The only way to tell where airflow is by finding something that moves that moves the same that moves the airflow. If you lick your finger and stick it in the air.
Ready? Ooh, sucker! See, you got it.
34.
3/4 of the way. All right, here, let's see Mr. Dollar. You did it right at the E, right?
Yeah. Okay.
Nice, ready?
The whole point is that you're supposed to.
But you're good. That's good.
Check it
Awesome.
out.
You figured it out. Actually, to be honest with you, it isn't just a skill. It's not that I'm sure faster. I know a secret about it.
So you have to grab it before.
Well, how do I know if I'm going to grab it before if I can't? If you don't tell me when you're going to drop it.
I don't know.
But here, let's say that Mr. Dalton grabs the dollar halfway in its fall. How fast was his reaction time? Okay. So what you do is you draw a picture. Got it?
And you plug in
So delta x is, even though that's the size of the dollar, what is delta x?
position if you figure the arrows into the
It's the
dimensional
change in position that the dollar fell.
Yeah.
How far
Okay,
did the
so
dollar
just
fall
using it as
before
a
Mr.
general
Dalton
thing. I
grabbed
thought you
it?
were
Like-
Well, if it's 16 centimeters,
Oh.
I would say it's about 8 centimeters I grabbed it.
Yeah.
Got it? So
Like half.
0.8 centimeters. That's delta x. Got it? What is its velocity initial?
0.
0. Thing that wasn't moving to begin with. What was the time? Well, that's what I'm trying to calculate. Plus 1/2 a. What's the acceleration of this thing?
Regular speed of gravity, 9.81 meters per second.
By the way, that's not 0.8. That should be 0.08.
Okay.
Wouldn't that be like no?
Yeah, it would be 9.8 meters per second squared. That's
Oh,
the
really? It's
acceleration of
9.81.
gravity.
No,
Okay.
it's 9.81 meters
Fine,
per
I'll
second.
do 9.81. Now I'm going to plug in the t squared, which we still don't know. Got it? Use your algebra skills. Solve for t. Justin, tell me what to do. All right, we can do that.
Distribute.
Just get t all by itself for now. Don't worry about the numbers. Can you see?
So what is half 10.81?
4.2 or something like that. Use your calculator. 4.9.
It's probably going to be close to
4.905.
So
All
we
right.
should really teach.
Okay, wait, but let's solve for t. I don't like doing numbers, by the way. I just want to solve for t.
Do the
Just wanna get
square
T all
root
this.
of the 4.9.
What would the square root solve?
No, she's absolutely right. You need to do the square root somewhere, but not on 4.05. Here, I think you guys are confusing yourselves. This is how I use algebra.
Oh,
This-
you have to isolate the variable.
There we go.
Square root both, find the square root of both sides, get all the numbers on one side and all the variables.
No, you did it opposite. She was right. You have to isolate the variable first, then square root the variable. Okay. So why don't we isolate the variable here? Why don't we just multiply up that 2? 2 times 0.08. We're going to drop down to 9.81. I'm going to worry about calculating everything in my calculator later. But I have t squared. I'm going to take out that t squared with the square root. Agreed? So, now plug that into your calculator. What is
If you turn it sideways,
You can do square root.
2 times 0.08 divided by 9.81? Then take the square root of that answer.
So it's 2 times the 0.08
2 times 0.08
divided by 9.8.
divided by 9.81 times the square root, or not times, but square root that.
That is 0.016.
0.0, oh, okay, you didn't take the square root. Well, that would be 0.004.
Right.
Right?
Yeah.
0.004. That's my reaction time, folks. I get it. I can catch a dollar. I can react in 0.004 seconds.
can we do it in
All right. So here's what I want you to do.
power of times?
Here's what I want you to do. All you got to do is this. We're going to take a meter stick. We're going to drop the meter stick. We're going to figure out what your delta x is. From the delta x, we're going to calculate your reaction time. Justin, get in here. We're going to calculate your reaction time. This is, by the way, Kiko, this is where I need your dad to help you out. Go get a dollar and swindle him with the dollar. Say, hey, can I borrow a dollar bill, Dad? And then say, if I can catch it, if I can catch a dollar, I get to keep the dollar. Or no, Here's what you should do. You should say, all right, if you can catch the dollar, you can keep it. But if you can't catch this dollar, then I'll take it. See if you can do it. Put your hand about an inch apart, and then put the dollar at the bottom. And drop the dollar. And it's really tough to catch. So since it's tough to catch, we'll catch a meter stick because a meter stick is a little bit longer than a dollar, and we'll be able to catch that. We'll be able to get our measurement for delta x, and then you guys got to use this equation to calculate what your time is, your reaction time is. All right? Then I'm going to let you know. Here's what else we're going to do. Then after that, do you text? You text? Do you text? Can you text with one hand?
Depends on how fast.
Well, it doesn't need to be fast. I don't text. I don't text with two hands. I just don't. I hate it. But anyway, well, then what we're going to do is I'm going to have you guys do the same thing and text each other while I drop the dollar. Or
We're
drop
gonna need
the
our-
thing.
we're gonna need
And I'm going to
to-
see, I mean, obviously, I think your reaction time is going to be a little bit slower.
Why don't we just type in the notes program? or
But I just
something?
want to see what the difference is. I've never done this lab like this before, so why don't we just try it out? We'll see what happens. Cool?
Your brain can't, man.
All right.
I can't multitask.
So Kiko, you got it? At this point, I finished. At this point, I finished the lecture. I'm actually going to be using this, which is what I printed out off the computer. It's basic. I have the lab up on the thing, and I'm just going to go through it today. So as I go through it, make sure you check it out. Are we cool? I don't know if you could hear me this whole time. I truly apologize, Kiko, if you couldn't. I don't think she's answering, so I don't think she is. All right. But for now, I'm going to push this computer back. We're going to make some room over here, and we're going to just do this lab inside of this office.
She said this is archived.
Yes, Kiko, I'm archiving this. I'm going to upload a YouTube video, which hopefully is a much better quality sound than what you're hearing right now, which is
Yeah.
almost nothing, I'm sure.
It's compressing it.
All right. Let's get some chair. Let's get these chairs out of here so we have some room, and we'll stand up and we'll do this lab together.
I'll get this out of
All
here.
right. Then for now, I'm going to leave this computer on and recording, and let's just do the lab. All right, Kiko, it's going to feel like I'm going to ignore you, but I've explained to you the instructions. I gave you the data, the lecture. You know the equations. So at this point, I'm really just going to focus on trying to get this lab. And what we're going to be doing is, the reason why I'm focusing on that is so that we can get a good recording, and then you can watch this archive later, and then really kind of understand what's going on this whole time. I don't know if you could even hear me that when I said that. All right, 1 second. All right, get that chair out. So we're going to take down, we're going to do this, we're going to take down some data. I'm going to basically turn it over to you guys, and I'm just going to stand and watch you. Ah. All right, so I want you guys to figure out how many times you want to drop this. You guys understand, all you guys got to do is put your fingers over here. And I put it on so it has a little bit of weight. The only reason is so it will fall straight. If not, it won't. Because
It won't fall straight because you can't account for the turbulence of the plastic.
well, it'll fall straighter than if it didn't have the paper clips.
That's the point.
So,
I don't know enough about physics to argue with it.
do you guys know that if I put more things on here, it won't fall any faster?
The terminal velocity can be reached rather easily.
Okay, that's a class experiment that you should have learned about in 8th grade. Aristotle said that things that are heavier fall faster. Galileo said, "You're full of it."
He dropped
He dropped
Well,
to.
isn't it?
He dropped a wooden ball.
You
on a
are
steel
currently
ball
the only
with
person in
Dr.
this conference.
terminal velocity, at which point it will change slightly.
Not taking into account air resistance, which is a really tough physics concept to teach. In fact, I don't think I'll ever get to the math that you'll be able to understand that.
Yeah, I was just reading it.
But for now,
Technically speaking, we're evaluating all these things as though they were occurring in a vacuum,
Yeah.
in which case it would hit the ground instantly.
all right. So, Daniel, you want to go? And here, Justin, you guys are lab partners. I'm the teacher. I stand over here and watch you guys.
Go.
No, don't say go.
Oh,
Just do it.
We both close it. Okay. And
And that's it.
Here, if you need a chair, you can stand on a chair.
that would be unfair. That would be only fair.
Doesn't even matter that like it's higher. As long as you're tall.
Yeah.
I'm the tallest person in this area, even without the chair.
I know that you're tall. All right, so now what are we recording?
34.
30, 33. I say 33.
Go for it. I'm at it. I'm actually going to help out the business on paper.
Okay, let's switch positions. You hold that up. I stand over here and see.
Move your hand down a little bit.
48.
46.
Sure, 46. Because
I clamped it, but I didn't completely close it.
Are you guys going to use one piece of data? Or?
Oh, you want to see like 3?
As many as we can, and then we.
No, wait.
I'm going to let you decide.
46 is mine. 46 is
Yeah,
mine.
yeah.
34 is yours.
Okay,
So this will be mine over here. 46.
Here,
So I'll
here,
do 1,
you can use
do
this.
2.
46. 30. 46.
Let's test 8 times and add
I'll go stand up on the
Here,
chair.
there you go.
What's it? Before 27. Right.
Uh, 61. We'll just do you again.
How many are you going to do?
3. And then we're going to average it.
All right. Like I said, I have no. I'm fine with you. You guys said it's my
36. 36.
Yeah, well, because our brains are getting used to it. At least in theory, if we did it every day, we would catch it. If we'd done it every single day. 25. Record
Right here.
25.
Can I try?
I can do all the averages right there on the screen.
Is Kiko still watching?
I don't know. All right, here, I'll try. You want to drop it for me?
Sure.
Are we going to do you two? Can we make you
Okay, right
It's up to
3.
you.
Right 3.
You guys want to do me?
Sure.
3.
Ready? Oh, it's. No.
I'm not going to record a no character.
13.
13.
Holy shnikes, Mr. Dalday.
9.
Nine.
Holy cow, Mr. Dalday, please. You're making us.
By the way, it's not inches, it's centimeters.
Oh, yeah.
Okay.
What?
Mr. Dalday, please.
Wait,
Mr. Dalday, please.
You're making us all look complete. You're making us all look like.
Just like a ninja. Would you actually catch an arrow over there?
You have the chance.
Someone actually fired an arrow at you with a crossbow, but you can't.
I don't know, do you guys think I can catch it?
There's only one way to find out.
It's done. What is that? Sometimes what you do is at a party you like hide a butter knife in your pocket, right? And you have your friend go like this, and you go like this, and then
And
they
they catch
put
it
it,
right-
and then you just take the butter knife and go like this.
Oh wait, what?
Oh yeah, the
Dude, like sometimes I mess with
That's
people.
an old movie trick. That
Pretend to
you
throw
use
that
to
thing.
make up for it.
Oh, I get it.
It's an old movie trick. You use jump cuts to make it look like you actually almost got hit with something, and you catch it right before it happens.
All right, here you guys do your thing.
0.6 centimeters.
So if this thing is a dollar is 16 centimeters, you guys gotta catch a dollar.
We wouldn't catch a dollar?
What if it's 16 centimeters?
Oh
right?
yeah. Makes sense. Wait, what's the trick?
Where's the string for this?
I won't tell you until after the lab. Because that will skew the data, right? Because that's another variable that we would change so you guys know the trick. But I'll tell you right after the lab, and then you can mess with people. It's not really even a trick. Alright. Over. You guys know what to do?
You want us
Work
to
together.
Why does that happen to all of them? Why should we work together? Share everything.
You realize now that we probably should have timed how long it took us to do it. Acceleration was
It was how long it is?
acceleration was gravity.
Oh yeah, what was that? 9 point.
Here, I was assuming you replace AT with 9.81 meters per second squared, or the average speed of gravity at the equator. Which is okay because we're so close to the
Okay, and then over.
By the way, I used to put whenever I write zeros, I put a slash in between.
I thought you wouldn't use the t squared because we already have a second squared. But then I
Oh,
realized
we have to square it.
because you're dividing it.
No. What you're looking at, Justin, is you're looking at the units.
You don't even need those units in there, right?
Yeah, well, you should keep the units in there, but what you're saying is, all right, this thing is measured in meters, right? This thing is measured in 1/2 doesn't have the units to it. 9.81 has meters per second squared, right? The time is measured in seconds, but you're squaring it, so seconds squared. That cancels out with that. You get meters equals meters. We know
So
this
it's just
equation
9.1.
does work. But for now, we're not. I guess you could. You still need that t squared. In fact, not only do you need the t squared, that's what you're solving for.
Why are we eliminating the seconds per second?
Because this has meters per second squared. This has seconds squared. So those seconds cancel out, but
You only
The-
use one.
the units work. You use that trick for the units, but the equation still needs that t squared.
You just need half it. You just need half of the 9.81. Didn't you already do that, Mr.
What
Dowling?
was it? It was like 4 point.
4.9, which
4.905.
he's not using a calculator, people. This is 100%.
I don't even have a good memory. I've just been doing this so. We're doing physics for like 15, 20 years now. Oh, you got close. That first two.
Yeah, because it's canceled out by the other T.
No, it's not.
Why does this T disappear?
Because there's a zero in front of it.
Oh yeah.
So it goes away.
He's right.
It had no.
Needs to be surprised.
If it had no
Okay.
coefficient, it would be then
And T.
is the then T's then no, but T
Wait, you know-
T equals the square root of 4.9. Do that right now. Get your
No,
phone
no,
out and do
no,
that.
wait.
Because you were evaluating T squared. Because if T squared equals 4.9, then this T would equal the square root of 4.9, which is
Oh,
No, it's not.
We didn't even factor in the
Yeah.
average.
Okay, then we would multiply it by the average distance that it traveled before we were able to
Yeah,
catch
no,
it.
she's right. She's right.
So
We have to multiply this number by the average.
So,
We'd have to create 3 separate equations. One where we multiplied it by 28.6.
yes, for the last time.
0.9, 28.6. 6 times 9 is 54. You don't have to get your calculator. I like to do this math by myself.
I'm sorry.
54, 8 times 9 is 72. Put the 2 carry the 7.
140.42. Stop! What did I say?
At least now I know what to get. You said 140.16.
19.
Okay, then 6 times 4 is 24. Put the 4 carry the 4 times 8 is 32, plus the 2 is 34, but the 4 carries 3. 2 times 4 is 8, 9, 10, 11. Okay, I did something wrong, didn't I? Oh, no, wait. I forgot that there's supposed to, since there's 1 decimal place each here, there would be 2. Wouldn't that be 2 decimal places?
Let's just use a calculator.
Okay. Let's use the 816.3 or whatever it was you got. So, is that what?
140.4. Wait, so it was the.
So then
That's
our
the time?
no, because he said we were close.
Oh, we
so,
have to square it.
So the time would be the square root of 140.14, and then it would be that's the t sub 1. Then there's a t sub 2 and the t sub 3 for every single individual reaction time that we have. So okay, just get out your calculator. Do this faster. Put in. Multiply by that. Just give me the number right now. So what was that? So what is T1?
11.8. Wait, why did we?
We're evaluating each individual reaction time set.
Oh, okay.
Okay, so or
11.8.
okay, 11.8. Since we're rounding it, we use the curve that equals sign. Okay, that would be.
And next one.
27.
Oh, no, I'm looking at.
Go back and fix your math. That would be the square root of
233.24.
or approximately
15.3.
at
94.9.
okay. Let's call Mr. Doldan. Finish the math. This way I put down. But the computer's getting confused because there's too much stuff in the front. Doesn't know what to track. Yeah, we just go on to the calculator and so much more. Yeah, the numbers don't lie.
Well, these seem a little bit.
We rounded them, Mr. Dollar, so they're not real. We rounded them to 3 simple 2 ones and 52. So.
You plugged in 4, didn't you?
What?
Or you plugged in.
No, we
You
plugged
plugged
in
in 9 and 47 and 28.
Yeah.
Wait, you didn't use the decimals? Why didn't you use the
Shh!
decimals?
You don't
No, I
explain
did
to
use
you.
the decimals.
You don't explain to her what your problem is. Go talk to her. And don't do it right in front of the camera.
The camera, so they don't have to stare at my backside while I'm having a discussion.
Well, that's why I have a glass board, because eventually I'm going to have us standing on this side of the glass board. Or we can just write on that. So
Backwards,
discuss
right
it.
backward. Write it and have the computer flip it forwards.
Yeah, that's what I usually do, but I didn't get the lights with it. No.
He meant put it closer. We stand behind it and write the equations backwards.
No, you don't need. I don't need to write it backwards. When I teach you guys, I teach and I write forward.
But it makes it backwards.
But I have a computer.
That's why all your T-shirts have backwards lettering.
Yeah, that's why I'm like, if you notice, all my t-shirts are backwards things.
Yeah. Wait, so what's wrong?
Well, what did you do wrong? Because look,
We didn't.
I just? All right. Can I catch the dollar? Hey, can I catch the dollar? Yes, I can catch the dollar. And we calculated out my reaction time was 0.004 seconds.
Wait.
Over here, you calculate because we put in 8 centimeters the last time, right? And I got 0.004 seconds. You
Wait,
put
so-
in 9 centimeters, you got 9
Wait, so what
seconds.
happened?
I really have 9-second reaction time. Ready, set, go. 3, 2, or ready, set, go. 2, 3, 4, 5,
You would be on the gun by
6,
then.
7, 8, 9. Grab. Do you really have a 15-second reaction time?
No, that is.
That is like literally if you are blind.
That's not in seconds. It's not in seconds. It's in microseconds or something less.
You
than a
figure
second.
you figure out where your mistake is.
You have to move the decimal over.
Sorry, that's what you're arguing. Why would you do that?
Because
Okay, how many times would
because
you
we
do that?
simplified it, so it would obviously be a number less than that. We don't have our reaction times aren't that bad.
No, yeah, I
That's
mean,
not yours.
obviously, no, what I'm saying here is like, look at what
Try
I'm
to see if I
saying
can
here.
position my hand based on the image on the screen.
What I'm saying
It
here
only
is
updates every.
look at your
only updates
times.
every
No,
60th of a second.
What's the frame rate on that thing? 12?
well, no, I don't know. But what I'm saying is, when you wrote down 9.7, you wrote down 11 or 15, all that kind of stuff. Is that a reasonable
No.
answer? It's not. So therefore, we must have made a mistake somewhere. You guys figure it out. If I were here just to save you every time you guys made a mistake, you guys didn't do it in your learning. So you talk about it with each other, calmly.
I'm going to try and position the camera in a way it doesn't show my backside.
Okay. Be patient with them, bro.
I'm trying. It's very difficult
I know.
because I talk very quickly.
It's an exercise for you. Figure out what you did wrong, because 11 seconds, 15 seconds, 9 seconds is not a reasonable answer.
Yeah.
So there's something you did wrong.
Here's the cup for your.
You guys are
pen.
close though. Keep going.
Does this have ink? But we're not evaluating it in seconds. It would be somewhere around 10 less. We can use logic to determine that obviously it would not be anything close. It cannot be a nanosecond. But it can only be a microsecond because that's how fast the neurotransmission rate is measured in. So it would be 100
Remember how you guys were erasing units?
Yeah.
You actually probably might want to go.
Can't do more. We cancel it out 2
Fine,
units at a
fine. You
time.
want me to go?
No. We cancel it out 2 units at a time. It's kind of simple. Yeah. About 2 units at a time. It's blatant. It's obvious to me.
T equals 2 delta x over a.
Oh, we forgot the delta x.
No, you didn't. You plugged it in.
We
Your delta x
evaluate
was
it for x.
right? 2 equals 2 delta x over a. Oh no, wait, the square root. I just saw it. I just put the 2 up here. I put the a down there. Took the square root.
Mhm.
Your calculus, so you got this. Right?
Yeah,
You
sure.
you took calculus last year.
So
You're gonna have to tutor me a little because I'm only in pre-cal.
do you guys agree with that? I mean, I didn't even do any complicated
Okay,
stuff.
yeah.
This is what you solved for earlier, right?
So I was using logic to just.
So wait. Here, look. What is A measured in? Let's make sure. Let's check the units. This is measured in seconds, right?
Okay.
What is 2 measured in?
Two is
There's
the,
an in units.
two is a unitless.
What is A?
A is acceleration and A is in meters per second squared.
Meters per second squared. What is X in?
X
That's
is
the place.
positioning, so we measure that in terms of that's the centimeters. X is the centimeters.
Do you see your problem?
Yeah, what
The
do we?
centimeters and the meters
The
don't.
meters and meters don't.
So we need a.
So this is actually this many meters. This many meters. This many.
And that means
Meters.
we're not supposed
So that
to
means
use.
you got to convert this into meters if you want to use 9.8 meters per second squared.
Oh, then we could have just put
Does that make sense?
Yeah.
Then we could have just used 9,180 centimeters per second. Couldn't we just use that? Or is
I
that
think it's too much. It's 980.
Okay, thank you.
981.
Sorry, 981. Then we just use that, and then we just
Yeah.
divide the resulting.
It would have worked out the same if you instead of changing that to meters, you change this to centimeters per second squared.
As long as we change one and evaluate it
Because
right
these
back
will
to the
cancel out,
original
right?
number when we finish
This is
equation.
1 over second squared. The fraction on the bottom flips over. So you have second squared over 1, right? Square root both sides.
Yeah.
And again, second equals second. So do you understand your problem
I'm
is
trying to make sure that.
you did this in centimeters.
Oh, there we go. No,
You did this in meters
Yeah.
per second squared. Don't make that mistake again.
Yeah, so
I'm glad you guys made it. I'm really glad. I'm glad I didn't let you struggle with it.
redo it.
No.
Just like the decimal?
Yeah, I think so. Well, what I would do is I'd probably just put it, I would recalculate.
Yeah.
So I can show you that
Go for it.
we're not. It's not in microseconds.
So we're going to get to the second half of this experiment.
Um,
Oh, we're out of time. I'll tell you what. Why don't we try this?
Now I have an hour.
Let's try this.
At least I got one.
Can you guys text each other? Give each other phone numbers. Is that all right?
Yeah.
No
Do you
problem.
mind?
no.
Yeah, let me just open up my.
And then what I'll do is I'll hold the thing. You guys text each other, and I'll drop it. And you guys catch it.
Oh, that's weird.
I don't think I can do that kind of multitasking.
I don't think I can either, actually.
Okay, we swap. Okay, start up a new contact entry, and then we swap phones and put in our video.
Don't just. I'll give you my number and you text me.
Okay, let's just.
You know what you said to
3, 4, 2.
what was your nonsense?
Send message. There you go. You want me to delete this
You
after?
have to do 808.
I'll be honest with you. I think you guys are gonna go so slow you won't even catch me.
Yeah.
So I'm looking for a string, and I'm gonna attach a string. Measure how far.
Okay, send message. Hold on, I'm gonna find.
Why don't we come outside and we'll try to do this? Yeah, I have to say on paper that's really Who's still there? You just have to admit that you're slow. All days. We're just gonna go outside. We're actually gonna do this thing over here. Alright, we're back on the video. I don't know if Nicholas can. I think she dropped out. Alright, Justin, your turn.
Hey.
Daniel, you wanna? Actually, you know what? You gotta do the texting because I do not text.
Oh yes, of course.
Alright, Justin. You gotta text. You cannot hold the thing now. You ready? Yeah. Your account is frozen. Are you gonna type code?
Yeah. Yep. Joke's on you, I wasn't even texting her.
I can't believe you touched it that quickly.
Well, my reflexes
My
are
texting
terrible.
skills.
Was that?
Probably. I don't know.
I could test without looking.
Same here, but only on a
Oh,
keyboard.
and so you were watching this?
I don't know.
You gotta let go.
Okay.
You have to start typing.
I am typing.
Okay. I feel the same way about texting, but I put all my concentration on it. See you, Luke. You can't close your hand like that. Okay.
I
Ready?
can.
I'm waiting for you to start texting.
Okay, I sent the message.
Okay. Type hello. 83. 83, write it down.
I couldn't even type hello.
I know, it's nerve wracking.
My brain got sent a bunch of junk. My brain got a bunch of junk.
You want to do it again? I want to try it out and do it again.
This is hilarious what we're doing.
Okay, ready? You give up. Ready?
I can listen. I can listen. I can use my ears now.
Okay. You have to open up your hand. A bit more. Yeah. Just want to be of your peripheral vision.
I have a peripheral vision that stretches back to a
Pinky's
little bit
touching
behind my
the thing.
ear.
And you're not texting. Open your hand.
I'm not paying attention to anything. Mr. Donahue, please.
What? She got better. No, actually, she did twice as bad.
Okay, can we stop?
I'm not. No.
I need that program that they're using. Tracker. 40.
48, 43, 40.
Yeah, 38.
Alright, so here's what I want you to do. Justin?
Can we leave, actually?
Yeah, you can. Alright. 48, 42, 43, and 40. Justin, you got null, 83,
No.
null. You didn't catch it. That's null. Alright. So here's what you want to do. I want you to calculate out your new reaction time. Then after that, I'm going to do some other things with you. But for now, calculate your reaction time without texting and with texting. Sound good?
Right now?
No. Here you go.
Oh, okay.
Lab's done.
Oh.
Did you guys
Wait,
like it?
what is the assignment?
Oh, no, I got started for the lab
That's this. That's the literally is this. Right here.
So we didn't do it?
We did it together, yeah.
So I don't have to do anything.
Not really. I mean, there's some questions you have to answer.
Oh, I just have
Because that's a sign.
Yeah, but you just take this data over here, plug it into there, and
Okay.
you've got it.
Hey, give me a minute.
But you're going to give me a little lab write-up, right?
Yeah.
All right. All right, and for that, I'm just going to finish off the class.
Make sure I write homework.
It's doing like a week.